Hey boys, hope everyone's doing all right. We've been thinking about, starting to think about what the graph of the sine function looks like, or cosine function. And although we're just beginning this exploration, this video is aimed at reinforcing what the sine function looks like as a curve. And we're also going to introduce some vocabulary, some ways in which we describe these cyclical or periodic functions. And then we're going to look at different ways to stretch and compress the sine and cosine function. So, here we have a nice applet from Desmos, and we have that unit circle here. And remember, the sine of any angle is just the y value, the terminal point of the unit circle. So, for example, the sine of 0, the y value of that point is 1, 0, 0 being the y value, therefore sine 0, 0, right? And so if we open up the angle, the sine value hits its max here at 90 degrees or pi over 2 radians. It goes back to 0 at pi, and it hits its min at 3 pi over 2, and there's a full cycle. Okay, so one full cycle, and it goes on forever and ever and ever, but this is one full cycle, right? And the time it takes to achieve that cycle is 360 degrees or 2 pi radians, okay? So this is a graph of one cycle of the sine function. Okay, there are infinite more cycles, just keep going around and around and around the circle more and more. Okay, we can go to the left, we can go to the right. But this is what the general shape of the sine function looks like. Okay, and very quickly, to reiterate as we did in our last video, why it looks like that. Okay, so what I want to do today is to kind of think about the sine function and introduce some language that we use to describe that function. Okay, so one idea is that the sine function or any other cyclical or periodic function is centered about what's called a center line, right? And the center line is a line about which this sine, in this case function, oscillates. It goes up and down and up and down, right? And symmetrically. So for this particular function, the sine function, here's our center line, right? It creates a line of symmetry, right? Actually, that's not true. It creates a congruent shapes above and below it. And that line happens to be the line y equals 0, okay? Now, about that center line, and again, we're looking at just one cycle here. There are infinite cycles that shape, copy, paste, copy, paste, copy, paste. That shape, sinusoidal shape, continues infinitely. So about that center line, the sine function rises and drops a certain distance, right? And that distance, it rises and drops. The maximum distance it rises or drops is called the amplitude, right? And so the amplitude happens to be technically the distance that a sine or cosine function rises or drops from the center line. In fact, the maximum distance, right? So if the center line is y equals 0, this hits it, of course that's 1, and this is negative 1. It's going to rise up to 1, and it's going to drop down to negative 1, right? Here's this is, of course, pi over 2, 90 degrees. And the y value is 1, right? It hits its max. Here's pi radians. Here's 3 pi over 2. And the point 3 pi over 2, negative 1. Right, so what we're doing, and here's 2 pi to give you some reference. This function, the sine function, is going to rise and drop 1 from about its center line, y equals 0, right? So that's how it gets up to its max of 1 and up to its min of negative 1. Right? It rises and drops 1 unit. That we call the amplitude. Okay. We have this other word for the length of time it takes for this function or cosine function or any cyclical trigonometric function to repeat itself. We call that the period. So the period is a length of time in radians or degrees it takes for a function of this type to repeat itself, to achieve a full cycle. Okay, and perhaps, obviously, that's 2 pi radians or 360 degrees. Right? Because after you go around the circle one full rotation, this function starts to hit values, repeat itself, hit values it's seen before. Okay? So the sine function oscillates up and down a distance of 1 max from its center line, y equals 0, And it takes 2 pi radians, or 360 degrees, to achieve a full cycle. And that yellow stretch is one of an infinite number of cycles. Okay? And all this comes directly from the unit circle. So the question is, how can we stretch and compress these sine, or in the future cosine, or any function? Okay? So to do that, we're going to take a look at a couple graphs. Right? One, I'm going to take a look at y equals, well, what if we put a 3 out front here? 3 sine of x. And what if we compare that to the sine of x? Okay, and I'm going to hit graph, and the blue is the sine, but the red is 3 sine of x. Now, what do you notice? Yeah, that's right. It's higher or lower. How much higher or lower do you think it is? Yeah, that's correct. 3 times as high or 3 times as low. So what we say is that affects the amplitude. Right? It increases the amplitude. Right? And in fact, in this case, the amplitude is 3. It goes all the way up here to 3. It oscillates up and down about still the center line, y equals 0, but it now goes up 3 instead of up 1, as in the normal blue sine function. Right? Now we're going up 3, and then from the center line down 3. Okay. So a coefficient of the sine affects the amplitude. It either stretches vertically, increases the amplitude, or how do you think we can compress the, yes, yeah, how about 1/2 sine x? Right? Well, what's that going to look like? Well, all the y values are going to be half of what they were before, therefore it's going to be half as tall. So that red function is 1/2 sine of x, and it only has an amplitude here of 1/2. Right? Its maximum is at pi over 2 radians, where we achieve a max of 1/2. Right? And here is the minimum. Oops. And that happens at 3 pi over 2, and the minimum is negative 1/2. Okay? So the general trend is this, right? When we have a coefficient in front of the sine, which we'll just abbreviate as A, and it's no coincidence we say that's A, because that affects, in no uncertain terms, the amplitude, right? How high or low this function achieves from its center line, right? So the amplitude for y equals 3 sine x is 3, right? It bumps all the way up to 3 at its max, and it rises 3 from the center line, y equals 0. Right? And it also happens to drop 3 from, oops, that should be pi over 2, from its center line. Right? And really what you have is the amplitude is really half of the total height, right? The total height of this 6 sine x is, 3 sine x is 6. Okay? But it's symmetrically kind of bumping up. It's oscillating 3 up, and then 3 down, and then 3 up, and then 3 down, infinitely about the center line, y equals 0. Right? Here's our center line. Okay? And the same thing occurs with 1/2 sine of x. Right? Again, we have a coefficient of the sine, which in this case just compresses it. Right? So here it only goes up 1/2, and then it goes down 1/2 about its center line, y equals 0. So to conclude, what we have is for any function y equals a sine x, the amplitude is going to be a. Okay. And really, we always use a positive value for the amplitude. So it's really the absolute value there. Okay. So that's how we can compress or stretch vertically a sine function or cosine function. What if, now let's have a little more fun, instead of multiplying the sine, having a coefficient of sine, what if we have a coefficient of x? So instead of sine of 3 sine x, what if we had sine of 3x? All right, see now the coefficients of the x term, not of the ultimately the y term. What do you think that's going to do? Well, let's see. Ooh. So here's the sine function and the blue one. And now we have this red sine of 3x. And what do you notice? Yeah, there's a horizontal compression. In fact, I like to say this sine of 3x has 3 times as much fun as the sine of x in the same amount of time. Right? So you can see 3 cycles. Here's 1, here's 2, here's 3 of the sine of 3x in the same time or same interval over which we see just 1 cycle of the sine of x. Okay? So the coefficient of x in this case gives us 3 times as many cycles, 3 times the fun in the same interval. Okay, well, how would we stretch it horizontally? Well, what if we had sine of 1/2 x, which is the same thing as x over 2? Right? That's now the red function going to give us half the number of cycles in the same interval or same amount of time, from 0 to 2 pi we're looking at in this case. Right? So it's stretching it out, right? Stretching horizontally. Okay, so to generalize, what really happens is when we have a coefficient of the x variable, which we can call the b term. So we already established the a, the coefficient of sine or cosine, is the amplitude, but we also have a b term here, coefficient of the x that's possible, right? As is the 3 here and the 1/2 here. Right? And what that term does, the b, is it either stretches or compresses vertically. Right? So really what that means is that the length of time it takes to repeat itself, achieve a full cycle, which is called the period, changes. B is the term that changes the period. Now recall the regular period for the sine of x is 2 pi, or 360 degrees. That comes directly from the unit circle. Now when we multiply that x term, the independent variable, by b, that period ends up getting divided by b. Now remember, period is the length of time it takes to achieve a full cycle. Length of interval, I call it time, but it's really an interval, to achieve one full cycle. That's what the period is. Right? And so, for example, if we look at the sine of 3x, right, which is the red function, we have 3 times the cycle. We have 1 cycle. Right? Here's a second cycle. Here's a third cycle. So we have 3 full cycles from 0 to 2 pi. Right? That's the interval we're looking at. And so what that means is the length of time it takes to achieve 1 full cycle for the sine of 3x, here's 1 full cycle, is not 2 pi, but it's a third of 2 pi. Right? So therefore the period for the sine of 3x is not 2 pi or 360 degrees, it's 2 pi over 3, or 120 degrees. Okay? Same thing here happens here with sine of x over 2, right? Right? We're looking at 0 to 2 pi here, that's the interval we're looking at, which is the period for the sine of x. But when we have a b in front of the x, an x coefficient, in this case it's 1/2, we have half of a cycle we're looking at, right? So to achieve a full cycle, right, there's now a full cycle of what would be the sine of x over 2. Right? Now we need twice that length. So what once the sine function in of itself had a period of 2 pi, sine of x over 2 has a period length of 4 pi, which is of course 2 pi over 1/2. 1/2 is a coefficient of x, right, which is 4 pi. Right? So that's how long it takes the sine of 1/2 x to repeat itself. Okay? So to conclude, here's what we're looking at. For any sine or cosine function, the same thing can be said. Right? We have 2 opportunities to compress or stretch horizontally or vertically. A is the amplitude, really the absolute value of A. And B affects the period. So the period will be 2 pi, the regular sine amplitude, length of time it takes to repeat itself, over whatever B is. Okay? So really what happens is that the A stretches it or compresses it vertically, and the B term stretches or compresses horizontally. Okay? Hope you enjoy this video. Miss you guys. I hope you're doing well.